For our last example, we've got two positive 4 microcoulomb charges and then one negative 8 microcoulomb charge. I'm going to do the same thing here. In this case, the 4s get 4 because they're both the least amount, and then 8 gets 8 because it has twice the charge of the 4s. So I'm not drawing 4 and 8 simply because those are charges. I'm saying that 4 microcoulombs is the least amount of charge, so that gets the bare minimum number of field lines, which happens to be 4, and then 8 is double that charge, so I give it twice as many lines. Now, here's where things get interesting. If we look at the two positive charges, they're both going to repel other positive charges. So what we show here is, much like we did previously, we show that they will repel positive test charges away from one another, but we terminate those lines in the middle, because theoretically, if I placed a positive test charge at the exact middle point, those repulsive forces would balance out, and there is a point in the middle where that charge just would not accelerate in any direction. It would be perfectly squeezed between those forces or those charges. That's why we represent that as such. We're showing that anything placed, if I assume that this point, let's say, is like here, anything placed to the left of that is going to be repelled this way. Anything placed to the right of that will be repelled that way. And in the middle point, there's going to be no repulsion whatsoever. So that's what we're trying to represent with these arrows. If we go further, well, now we can show that these will curve away because any positive test charge placed, let's say here, is going to be repelled up by the positive 4 microcoulomb charge below it and away by the 4 microcoulomb charge to the right. So if we look at that, you wind up getting curved away because you're getting both repelled upwards and to the right. So you wind up this line of curvature acting in the opposite direction. All right, we can add the other one on the other side because that's just going to wind up going away because the positive 4 and the positive, everything's repelling that to the right. I can then continue as we did on the other side, like in the previous example. We know the positive charge is going to have lines that terminate at the negative. So then moving outward from that, I can then do the, moving outward, connect the positive outward pointing lines from the positive 4 that terminate on the negative 8. And I'd like to draw a bunch more lines that go from the positive 4 to the negative 8. Again, I can't connect them, so I just show that these lines likely would have come from these positive charges and terminated on the negative. All right, this is definitely not something that's very easy. I have additional methods I can show you using kind of vectors and some geometric principles, which I did not discuss in this video that may help you. So if you've seen these examples, you're still kind of confused, you don't understand why these lines curve, let me know and I can show you from a vector standpoint why exactly or where this curvature comes from. But in the meantime, if you are able to kind of visualize what would be happening to a positive test charge that I placed at these different points, it may make sense.